You'll have some time. These notes won't take very long. You'll have some time to finish. Peter's close, please.
What if you can't cross anything out?
I don't know. I'll look at it once we get done with these.
You told me to finish the one I'm working on.
Just head back. I'll look at it in a second.
So you lied to me.
Okay, computers away, please. We're going to start this next section. We'll finish this next section, page 86, tomorrow, so leave some space tomorrow.
Sorry, Callie. What's the point of starting tomorrow?
Because you can start some of the homework. Because a few people are getting close to done. Okay, so as I look at these, we are adding some of rational expressions. This is part 2. So this is going to be dealing with rational expressions that do not have common denominators. So first thing you're going to need to do, here's my steps. Steps with the 2 steps. 1. Okay. First step is to get the common denominator. And you've worked with common denominators before, but never probably with like expressions, with variables. So when I get the common denominator, you are going to find the smallest expression that includes everything. And it's kind of hard to put into words exactly how to do it. You kind of have to just practice. But this is kind of, I try to make it as straightforward as possible. So the GCF, the greatest common factor, is the common denominator, wrong thing. Common denominator is the smallest thing that they will go into, my denominators will come into. Now, I'll talk about some strategies as we look through a couple of these, but that's kind of what we're trying to get. Now, once you get common denominators, it's exactly like we did last unit. So once you get common denominators, you just add the numerators together. And then you may have to simplify. Sometimes you won't, but sometimes you may have to. But just be on the lookout for that. So it's the same as we did last unit, except we have to deal with common denominators first, which is going to make it trickier. Okay, so that's why we're taking our time with this, because I want to be able to work out some of the problems, because it kind of involves a lot of different stuff. So let's look at a couple examples today. Leave a majority of your paper for tomorrow. Let's say I have one like this. 5 over 6y squared plus 5x over 3. First thing I notice is that I am adding rational expressions. I'm not multiplying, I'm not dividing, I am adding. So adding and subtracting, we cannot add the numerators together until I have common denominators. So what we need to look at here is we need to look at my two denominators, and I want the smallest thing that both of them can go into. So as I look at my two denominators, this is 6y squared, this is 3. So when I identify my common denominator, I want the smallest thing that both the denominators go into. Now, here's a hint. Look at your denominators first. So look at your bigger, listen up, look at your bigger number and see if it will go into it. So 6 is my bigger number. Will 3 go into 6? Yes. So 6 is so you're kind of looking at it as a number part and a variable part. So look at your bigger number. If your smaller number goes into it, then that's your common denominator. Common denominator is 6. That's your number part. Your coefficient. Now we have to look at your variable. You have to include all the variable parts. So since this has a y squared, you have to put a y squared with the common denominator. You have to include everything that's in the denominator in one way or another. Now, as we look, and you've dealt with this before when you've dealt with having to get common denominators, we need to look at each fraction, and we need to decide what I need to multiply the numerator by, the top and bottom by, to get that common denominator. Start with the fraction on the left. The denominator already has a 6y squared. Do I have to multiply this top and bottom by something to get 6y squared? No, it's already there. So that stays 5 over 6y squared. If a fraction already has your common denominator, you don't have to multiply it by anything because it already has it. The second fraction is 5x over 3. Look at your denominator. What do I have to multiply 3 by to get 6y squared? 2y squared. So you can do these individual steps, but it's going to kind of get tricky as you have to multiply both sides and keep track. So that becomes plus, what's 5x times 2y squared? 10xy squared. The variables go in alphabetical order, so x come before y squared. And on the bottom you have 6y squared, which we wanted to get because that was my common denominator. Yeah, you can. Do I have common denominators? Well, you can put them together. Do I have common denominators? Yes. So you add the numerators together. Even though you can't really combine them, you can still write it as 5 plus 10xy squared over 6y squared. And if I look at simplifying, look at your coefficients. Can I divide 5, 10, and 6 by something? No. Do they all, if I look at the top, can I factor anything out of the top? I cannot, because this y squared is separated by a plus. It's not the entire thing, it's just this xy. So that is my answer. Okay? So these are kind of straightforward ones. We'll get to harder ones tomorrow, but I at least wanted to kind of get you started with this. Let's look at another one. Let's look at one like this one. We may have to add a sheet tomorrow. We'll see. It's okay. M plus 4n over 3 plus 6m over 2n. So, I'm sorry, m plus 4n all divided by 3 plus 6m over 2n. We are adding rational expressions. You cannot add the numerators together until you have common denominators. So look at your denominators. I have a 3 and a 2n. What is the smallest thing that 3 and 2 go into? 6, and then you have to include all the variables. So it's going to be 6n. So I kind of like looking at my coefficients first and then kind of tacking on the variables. 2 and 3, lowest number is 6, and I have an n. So then you look at each fraction separately and you ask yourself, okay, look at your denominator. 3 times what gives you 6n? 2n. So I have to take the bottom times 2n, and I have to take the top 2 times 2n. Now, when you take the top times 2n, be careful. This m plus 4n is a binomial, so it goes in parentheses. Now, why do I have to put a 2n over a 2n when I multiply it? Why do I have to multiply the top and bottom both by 2n?
It's just the rule.
Right, but why is it the rule? Because rules are going to make more sense if you actually know why we're doing it. Why do I have to multiply the top and bottom by the same thing?
You always have to multiply the bottom by the top.
To keep it what?
It's the same.
The same. Why does the top and the bottom have to be the same when I multiply? What's 2n over 2n equal to? 1. Does multiplying by 1 change anything? No. So that's why you have to multiply top and bottom both by the same thing, so it gives me 1. So I can do that because it's basically multiplying by 1. So we can go ahead and distribute. If you want to do each fraction separately first, that doesn't matter. So as I look on the top, I'm going to have to take that 2n and I'm going to have to distribute it because it is 2n times that binomial. I'll put them in alphabetical order. So it would be 2mn, because it's 2n times m, so 2mn, alphabetical order, plus, what's 2n?
8n squared.
Okay, yes, 2n times 4n is 8n squared over 6n. plus, look at your second fraction. I have a 2n in the denominator. 2n times what gives me 6n? 3. So I have to multiply top and bottom by 3. I have to multiply top to keep it the same as multiplying by 1. My top will be 18m over
Whoa. Oh, wait, never mind.
over
Over 6n.
6n. My denominators are the same, so we can add the numerators together. When I add them together, I can't really combine anything, so it just stays 2mn plus 8n squared plus 18m over 6n. Now look at your coefficients. Is there anything I can take all my coefficients and divide by?
2.
2. So take all your coefficients and divide by 2. This will leave me
1.
1mn plus
4n.
4n squared plus
9.
9n.
over 3n. So that's kind of what I mean when I'm reducing. Usually you're not going to be able to factor something out, but sometimes you're going to look at all your coefficients and be able to divide by something. Like in this case, you could divide all by 2. Okay, I want to look at one more. You'll have some time tomorrow to finish the homework, so don't you worry. Okay, let's look at one more. Example 3, I'm using the whole page. We'll add a page tomorrow. That's fine. Example 3, 2x plus 4 over 12xy. Now, you will have some where you see one of the terms is a rational function. Like 2x is just a monomial. So just put it over 1. Yeah, so if you ever just have like a non-fraction, just one thing, a monomial, you just put it over 1.
Well, that's pretty easy. Then you just multiply that and like 12xy.
Right, so now I have 1 and 12xy. Well, if I think about common denominator, what's the smallest thing that 1 and 12xy go into? 12xy. So my first fraction, I have a 1. What do I need to multiply top and bottom by to get a 12xy? 12xy. So the bottom times 12xy, the top times 12xy.
So you get 24x squared y.
Okay, so 24x squared y over 12xy. Okay, yep. If I look at my second fraction, I already have a 12xy. I don't need to multiply it by anything, so I keep it 4 over 12xy. Yeah, I have common denominators, so I can add the numerator, which doesn't really, I can't combine them, so you just keep it 24x squared y plus 4 over 12xy.
Ms. Keller, I have a question.
Yep, you can divide everything by 4. So take everything and divide by 4. So that will give me
That's what I wanted to know.
6x squared y plus 1. You have to keep the 1 there because you divide by 4 over 3xy. Now you can't cancel out anything with the xy because I have a plus 1 here. That's your answer. So it takes a little more work. We're going to look at kind of harder ones tomorrow, but this kind of gets you started. At least you've kind of seen this. So you can start the homework. Basically, it's going to be 21. I believe it's 21 through 25 on the homework is what you can do now.
Sum of rational expressions, part 2.
Yep, 21 through 25 is what you can do now. But you'll have time tomorrow to work on it, but I just want to get started.
Wait, 21 through 25.
Yes, there's only 5. I split up the next section.
The sum of rational expressions.